Today my presentation is about modular arithmetic. What is modular arithmetic? Well, it's when you find the remainder when one number is divided by another. It uses the formula x mod y, and it works how using any hand of a clock moves. For these examples, we won't be needing any calculators, so it's going to be very easy to work out. But how exactly is it used? Well, an easy way to do problems like this in math, such as find three numbers when divided by a number give you a remainder of 12, you can use mod to do it very easily here without doing the whole long division thing. Once you find the two numbers you think will work, do the first number, mod the number it will be divided by, and the answer you get will be the remainder. Other common uses for modular arithmetic are for ISBN numbers. They use mod to find errors. An ISBN number is an International Standard Book number. They're used to track and identify books, and they're very important so libraries know what's in their inventory and if their inventory is correct. It's also used in cryptography and computer science. It's used in many algorithms. What is an algorithm, you may ask? Well, that's something a computer does either all the time or when a certain thing happens. For example, when you press the shift key on your computer, it knows to make every letter you put after that a capital letter. The algorithms that mod is used in are Advanced Encryption Standard and International Data Encryption. That's because mod scrambles the answers that you get with a string of numbers. How this works is basically you and a friend can agree on numbers, then you can use equations separately, including lots of mod, to find the hidden number or message that you originally had. How it works in code is the exact same way, except it's way more complicated. The easiest way to do modular arithmetic is to make a diagram. Then you mark down the numbers from 0 to x minus 1. In this case, x is the number after the word mod. You do 0 to x minus 1 because you want a total of x numbers. For example, if you have 5 numbers, you want to mark from 0 to 4 because that makes a total of 5 numbers starting with 0. Then you want to go around the circle diagram starting at 0, y times. In this case, y is the number before the word mod. Let's look at some examples so you can hopefully understand it better. Let's solve 8 mod 4. First, we draw our circle. Then we add our 4 numbers from 0 to 3. Now we go 8 times clockwise from 0, and we can see which number we land on. As you can see, we have our diagram right here. You go 1, 2, 3, 4, 5, 6, 7, and 8 times, which gives you an answer of 0. Just in case you can't see any of this, I'm going to draw it for you right here. This is our beautiful little circle. Now we put in 4 numbers. Now we want to go 8 times clockwise. Clockwise is the way a hand of a clock moves, which is this way, just in case you haven't looked at the clock before. As you can see, the answer is 0, which we know is correct because on our calculator we do 8 divided by 4 and we get the answer 2 without a remainder. Now let's solve 12 mod 7. I have a bigger diagram this time, and you do the exact same thing. You get total 7 numbers from 0 to 6, and then you go around clockwise 12 times. But what if you get a negative number, then mod a positive number? Well, what you would do is you want to go counterclockwise, the total opposite way that a hand of a clock will move. I'll show you how to do this. So what you would do is you mark down the total of 8 numbers, like this. Now you have 7 numbers, you can go ahead and go counterclockwise, which is this way, 13 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. As you can see, the answer is 3, which is exactly what we got there. How would you put this into a problem? Well, if you do negative 13 divided by 8 in your calculator, you'll most likely get a negative number, or negative x, and then you get a string of decimal numbers. What you want to do is you want to take that negative x, get rid of the decimal numbers, and just add 3 at the end. That will be your remainder. Now I want you to solve these on your own. I'm going to get pieces of paper. So we want you to solve 10 mod 3, and I've already done the diagram for all of you. If you got the answer 1, then you would be correct because you went 10 times clockwise starting with 0. Thanks for watching.